Good morning, students. I am Nishresh Bagalwadi, your science teacher, Sunfelt Learning Solutions. In the last class, we discussed regarding the carbon and how the covalent bond occurs in the carbon and its compounds. So here, covalent bond is the bond formed by sharing the electrons. Here, the electrons are not gained. Here, the electrons are not lost. So there will be no formation of charges at all. So that is why this will not conduct electricity. Right? So here, today we are going to discuss two more special properties of a carbon. These properties you cannot see in other atoms. If you see also, they have certain drawbacks we can see. Okay. So here, as we know that carbon forms the covalent bonds by sharing the electron. We saw the structure of methane, right? So it covalently bonded with four hydrogen atoms. Like this, carbon has a capacity to share the electron. It has a capacity to bind with its own atoms. It has a capacity to bind with the other atoms. This property of carbon is called as catenation. So today we are going to study regarding versatile nature of carbon. Versatile nature of carbon. Versatile means special, outstanding, unique nature. So carbon as the property to bind, to bond with other atoms of carbon or with other atoms itself, other atoms of different elements, other atoms of different elements. Okay, so this property of a carbon regarding the bond formation with its own atoms or with the other atoms, this property is called as, it is called as catenation, guys. So the carbon can be bounded or can be linked with the other atoms of carbon in the form of long chain, in the form of a branched chain, sometimes in the form of the rings. So here you can take an example of a glucose. So glucose C6H12O6. It's C, 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 C. So again, it will be binded with a hydrogen atom, two hydrogen atoms each. So here what happens, as you can see, it is in the form of a ring. So atoms, carbon atoms can be linked in the form of long chains, or they can be linked in the form of branched chains, or they can be linked in the form of rings. And the one more property is sometimes carbon atoms will bind with the other atoms by a single bond. Sometimes they will bind with a two or three bonds, triple or double bonds. So the compounds of carbon which are linked by a single bond are called as saturated compounds. So here there will be single bond between carbon atoms. So these compounds, these carbon compounds are called as saturated compounds. Similarly, in some compounds we can see double and triple bonds between carbon. Okay, so these compounds are called as unsaturated compounds. Unsaturated compounds. So this catenation property is a gift for the carbon to form or to produce lot of molecules. And yet now it is said that the organic chemist just calculated that millions of compounds of carbon we will use in our daily life, guys. There are more other compounds which we don't know yet, right? So here, These are two types of compounds depending on the number of bonds between the atoms of the carbon. The first one is saturated, where carbon atoms are linked by single bond. The second one is unsaturated, where carbon atoms are linked by double bonds and triple bonds. Right. You can ask me why other atoms cannot exhibit certain characteristics. We have other atom which is named as silicon. Okay. Silicon and also silicon, Si. So it is also has a capacity to form long chains with hydrogen. Okay. It is also tetravalent. It has also 4 valence electron. But the main thing is silicon is more reactive and unstable, while carbon is most stable atom. Carbon is stable. So here, carbon is stable. That is why many compounds are formed with the carbon other than the other atoms which have a same property like a carbon. Right. So silicon is a more reactive than compared to carbon. Now we will discuss the other character or the other versatile nature of the carbon, guys. So here, carbon, second property, carbon is tetravalent. Carbon is tetravalent. So regarding the valency, we learned in the ninth standard. Valency means with how many electrons present in the valence electron, that many bonds can be formed by the atom. So here is tetravalency means simply remember carbon has 4 hands. Carbon has 4 hands. See here we have 2 hands. By considering 2 hands, you can shook your hand, you can shake your hand with the 2 persons simultaneously, means at the same time. Similarly, carbon has 4 hands, means it can shake its hands with the 4 persons simultaneously. That is the unique property or a special property of a carbon, which is called tetravalency. That is why many compounds of carbon can be formed due to this property, that is tetravalent. It has 4 hands. It can form 4 bonds. Means we can say simply it has a more friendly character. Okay, because it has 4 hands, it can make a friends very soon. Right. So here, as we know that silicon, germanium, so these also have a tetravalency, or these also have the 4 hands, we can say. But the compounds are not formed. Many compounds cannot be formed using these elements because due to their larger size. What is the effect of size here? You can ask me. See, the carbon atomic number is 6, right? And it has a very small nucleus. Its atomic size is very small. Carbon atomic size is small. Okay. Uh, so the electrons, it has only 2 shells, K and L, right? 2 plus 4, right? So the attraction between the protons and electron, the nuclear attraction, the attractive force between these protons and electron, or the attractive force by the nucleus will be very strong in the carbon due to its atomic size, due to its very small atomic size. That is why compounds formed by the carbon will be stable, because of its small atomic size. When you see the atomic sizes of silicon and germanium, they have considerably larger size. Larger size means lesser attraction between the nucleus and the electron. Lesser attraction means electrons will be lost very easily. So the compounds formed by these will not be stable like that of carbon. So due to its smaller size, due to its tetravalency, carbon can form cross together of compounds. Okay, so these are the two main properties, two versatile nature of the carbon, which makes it special, right? So here, as we discussed regarding the carbon as the property, regarding the catenation property, as well as regarding the tetravalence property, and we got to know that millions of compounds can be formed by the carbon. So to study these compounds, it is very vast subject to study about the carbon and its compounds. It is a very vast subject, we can say. That is why carbon and its compound, study of carbon and its compound has given a separate branch in chemistry, which is called as organic chemistry. So organic chemistry, the organic chemistry, what we call, it is a branch of chemistry. It is a branch of chemistry which usually deals with the carbon and its compounds. Majority of this chemistry deals with carbon and its compounds. How the compounds are formed, what are the other properties of the carbon. So this all we study in the organic chemistry. Along with that, we have two more branches of chemistry, which are physical chemistry and inorganic chemistry. So these are the main three branches of chemistry. Again, along with them, we have many other sub branches. So physical chemistry and inorganic chemistry. Okay. So these are the branches of chemistry. Study of carbon and its compounds we will study in organic chemistry. We will study in organic chemistry. Now, as I said, the compounds formed by the carbon can be binded, can be linked with the other carbon atoms by a single bond. So such compounds are called saturated. When they are linked by double or triple bond, such compounds are called, we can say, unsaturated compounds. Okay. So here, let us discuss this saturated and unsaturated compounds in detail, guys. First, we will discuss saturated. So here also we should recall the concept of what you can say, the electron dot structure. So in the last session, we discussed the electron dot structure of one of the carbon molecule, carbon compound, which is methane. Today we are going to study about one more carbon molecule, so which is called as ethane, which is called as ethane. Ethane. So ethane formula is C2H6. C2H6. For to draw the electron dot structure, you should know the formula. Then it will be very easy. So let me draw. First, we will write the valence shell of the carbon. 1, 2, 3, 4. Another one. 1, 2, 3. We can write this carbon is there. I will write this electron belongs to this. Okay. So let us draw. Okay, let me write the electron configuration 2 and 4. So 4 electrons are there here. 1, 2, 3, 4. 1, 2, 3, 4. As they are binded. So here the electron for this carbon is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 electrons are there. So to make it stable, we need 3 more electrons. To make it stable, we need 3 more electrons. Then it becomes 8 electron in the valence shell, in the outer shell. So for that, what we are going to do, as we know, H6 are there. H6 are there. So here, we will consider each electron. This needs 4 electrons. This needs 4 electrons. Each atom needs 4 electrons, right? Uh, so Let me consider hydrogen, 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 hydrogen. So hydrogen has one electron in its outermost shell. Okay. When it is shared, when it is shared, now count the electrons around this carbon. 1, 2, 3, 4, 5, 6, 7, 8. It got octet electronic configuration. Similarly, this carbon 1, 2, 3, 4, 5, 6, 7, 8. 8 electronic configuration. So how many carbon are there? Carbon and carbon are attached with a two pair of electron, that is single, and along 6 hydrogen. So let me write here. See here. This is the electron dot structure. Skeletal structure. How to draw skeletal structure? I will show you. Just a minute. So carbon and carbon. Okay, they are linked by single pair. So single pair. Now this carbon has 4 hands, right? 1, 2, 3. One is shared with this. This also has 1, 2, 3. So these hand is given for H by sharing the electron. 3 hydrogen atoms, H. So hydrogen, one electron of carbon will be shared with it. This electron will be shared with it. So this is the ethane skeletal formula of ethane, which is C2, C2, H, 1, 2, 3, 4, 5, 6, C2, H6. So here, carbon and carbon are linked by a single bond. When carbon and carbon atoms are linked by a single bond, such compounds are called as saturated compounds. Saturated compounds. Similarly, we will take other example. We will take other example, which is propane. Propane, okay? Propane. Prop means three. 3 carbon atoms. 3 carbon atoms. Okay? So C 1, 2, 3, 4. C 1, it's electron atom here. 2, 3, 4. C, this electron atom here. 1, 2, 3, 4. So, okay. And 4 electrons. Why I am drawing 4 electron? C, Kl, 2, 4. Valence electron will be 4. That is why you should draw 4 electrons around the carbon. Right? Next. Now, all the 3, we can say, carbons are linked by a single bond. 2 pair, 1 pair, 1 pair. Yeah, 1 pair with this, 1 pair with this single bond. Okay. Now, let me consider the number of electrons with this. Right? So with this carbon, 1, 2, 3, 4, 5. So it needs 3 more electron to become 8. Right? Then this 1, 2, 3, 4, 5, 6. It needs 2 more electron. 1, 2, 3, 4, 5. Again, it needs 3 more electron. So here, as you know the formula, let us write hydrogen, hydrogen, hydrogen. Here also hydrogen, hydrogen as it needs 2. Then hydrogen, hydrogen, hydrogen. And hydrogen valence electron is 1. So 1, 1, 1, 1, 1, 1. It needs 1 more electron to become completely filled. So it says carbon electron. See here. Okay. Now check the electron with this carbon mass. 1, 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Right? Same this way. 1, 2, 3, 4, 5, 6, 7, 8. Done. This carbon. 1, 2, 3, 4, 5, 6, 7, 8. So how many carbon atoms are there? 3 atoms, right? 3. How many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8. H8, right? As carbon are linked with a one pair of electron, C we can write, let me write the skeletal formula. So here I can write C, C, C. Okay, one pair of electron. Then, so these all linked with hydrogen, hydrogen, hydrogen. These are 3 atoms. This carbon has 2 hands. 1, 2. Okay, so here it needs only 2 hydrogen. This has only 1 hand. Other 3 hands are free. So 1, 2, 3. This is a skeletal structure of propane. So this is a propane. As we know that carbons are linked by a single bond. This is also an example of saturated compounds. So these saturated compounds like ethane, propane, these all are not most reactive compounds. These are less reactive compounds. Okay. So next one is next regarding unsaturated compounds, we will learn in the next session. Before that, as I said regarding propane, methane, ethane. So you want to know the basic concept of it. I'm going to tell that. So here, depending on the number of carbon atoms linked, okay, depending on the number of carbon atoms based on number of carbon atoms in a compound, compounds are named as follows. We will learn this, and along with this name, they will include how many bonds are formed. How many bonds are formed? They will intermix both the names. First, we will learn this. If any compound has only one carbon atom, carbon atoms, and it is name. Okay. If any compound has one carbon atom, it is called meth. If atom has two, it is called eth. If atom has three, it is called prop. If atom has four, it is called tetra. If atom has five, it is called penta. 6, hexa. 7, hepta. 8, octa. 9, nano. 10, dec. So here we will be having here, meth, eth, and prop. So these are the names depending on the number of carbon atoms. Along with this, like you saw, no, propane, ethane. So in propane and ethane, when you compare propane, okay, and ethane. So here what is common? Ane is common. Why? Because both the compounds are linked. In both the compounds, the carbon atoms are linked by a single bond. When they are linked by a single bond, or when they are saturated compounds, the suffix means the last word. The suffix will be having ane. It will be having ane. Okay. So this is about the naming of carbon compounds depending on the number of carbon atoms as well as if they are saturated. Let us learn about unsaturated compound in the next session. I hope this session is clear for you. If you have any doubt, please do ask. Okay, we will end up the session here. Take care. Have a nice day. Bye-bye.